Good day. I'll be talking a bit about the work that I did during my PhD in 2014 on the Belgian coastal zone. Now, the Belgian coastal zone is part of the North Sea, and surprisingly, it's in front of the coast of Belgium. What it's important to remember, to know, is actually that it's a very intensively used area. So there's a lot of dredging, there's a lot of fishing going on, like you can see here on the map of the fishing pressure in front of the North Sea. So what we did in 2004, and this will actually affect the seafloor, the sediment. Because if you look, for example, at a dredging ship that's losing its cargo, it's basically spewing the seafloor back into the sea, which will sink down and then affect the sediment below. And bottom trawling, which is basically the drawing of very big nets and metal poles over the seafloor, will also leave tracks and inadvertently affect what's happening down there. So what we did was, I had a 12 months of sampling campaign on the Belgian seafloor, Station 130, with the Simon Steven, in which we took course, undisturbed sediment course of the seafloor nearly every month. And what we saw was, if you look at the time axis, is that in January and May, the cores were very, very similar. There was a very thin brown overlying layer, oxidized layer, followed by a light gray clay that changed into a darker clay if we go deeper. We saw the same later in the year, in September to November, also a very thin layer, near identical cores. What we did see in June, surprisingly, was that the sediment, the appearance completely changed. There was a very thick, 15 centimeter brown fluffy layer which overlaid the darker clay. So it's immediately clear that something happened between May and June. So if you take the two likely causes of this disturbance, which is dredging and bottom trawling, we can actually make a mathematical description of the sediment processes, and we can feed this into a geochemical model. What we do then is we let it calculate first the steady state in which there is no disturbance, and then we add the disturbance, which is either dredging or a bottom trawling, and we let it recover. What you immediately see is that the red line, which is the dredging scenario, follows the data much more closely than the bottom trawling. But also, in September, the system was not yet in a steady state, so it didn't recover back to its original values in May, even though the sediment appearance did change. So what the model can teach us, first of all, that dredging was the likely culprit, but also that the effects of dredging and bottom trawling are very, very similar. So to sum this up very shortly, is actually that dredging and bottom trawling, or the anthropogenic usage of the seafloor, does have a big impact on the seafloor. It will disturb it, also geochemistry, and it will take more than a year or more than a year to recover back to its original steady state. If we compare this, that we need almost a year to recover, and we know that the North Sea is trawled somewhere between 1 and 3 times a year, but also that dredging and deposition occurs nearly continuously throughout the year, we can actually say that there's a very, very big anthropogenic fingerprint on the coastal biogeochemistry, both here and most likely across the globe. Thank you very much.